Hi Year 7, this is our second lesson for the topic of angles. In this lesson we're going to look at angles at a point. Let's have a look at what we learnt in the last lesson. We learnt all about points, lines, intervals, rays and angles, the types of angles, how to name angles, how to mark equal angles or equal intervals, and how to measure angles. So we're going to look at angles at a point. Now angles at a point will share a common vertex. Do you remember what a vertex is? It's the point where two lines or two rays meet. So in this case, this is the vertex here that all of these four angles share. So here's some examples of angles at a point. You can see this one here meets at this point. These two here meet at this point, and these two meet at this point. Now sometimes they're next to one another, and sometimes they're not. Which leads us to adjacent angles. Now adjacent means next to. So adjacent angles are next to one another, but they have to share a common arm and a common vertex. So have a look at this diagram. Angle ABC and angle CBD are adjacent angles. They share a common arm, which is BC, and a common vertex, which is B. These angles are not adjacent angles. Can you tell why? They do share a common arm, but they have a different vertex. This angle has a vertex at B, and this angle has a vertex at C. These angles aren't adjacent either. They share a common vertex at B, but they don't have a common arm. There are two adjacent angles that have special names. And the first one is supplementary angles, and they're adjacent angles that will actually make a straight line, or 180 degrees. And then there's complementary angles, and they're adjacent angles that will form a right angle, or 90 degrees. Let's look at supplementary angles first. So there's an example, and you can see that angle ABC and angle CBD are adjacent because they have a common arm and a common vertex. And because they add up to 180 degrees, they sit on a straight line, they're supplementary angles. We can also say, for example, that 75 degrees is the supplement of 105 degrees. Okay, can you see how these two numbers add to 180 degrees? Here's complementary angles. They are adjacent angles that add to 90 degrees. Have a look at the diagram. We have a common arm and a common vertex, and they add up to 90 degrees. So angle LAM and angle MAD are complementary angles. We can say that, for example, 50 degrees is the complement of 40 degrees because 50 plus 40 is 90. Angles that make a complete revolution will add up to 360 degrees. So in this case, A plus B plus C plus D is equal to 360 degrees. Now these angles, some of them are adjacent, some of them aren't. For example, angle D and angle B are not adjacent, they're opposite one another. But they are all angles at a point because they've got a common vertex. Alright, one last type of angle to learn. When two lines intersect, the angles vertically across from one another are equal. Can you see those highlighted angles there? So angle LMN is equal to angle PMQ. Now these angles are called vertically opposite angles. Can you see another pair of vertically opposite angles in that diagram? How about this one? Angle LMP is equal to angle NMQ. So just before we move on, let's recap. There are four types of angles at a point that we consider. The first one is complementary angles, and they're adjacent angles that add to 90 degrees, like this. Supplementary angles are adjacent angles that add to 180 degrees. Now one of the ways that you can remember this, a quick trick, is to look at this first letter here. So this C that's at the beginning of complementary, or K sound, can stand for corner, and the S sound, or the S sound, can stand for straight line. So that's one way to remember. We also have angles in a revolution that add to 360 degrees, and vertically opposite angles that are formed from two straight lines that intersect one another. Okay, let's move on to reasoning in geometry. When we solve geometrical problems, we have to write down our reasons, and our reasons are written in brackets after the answer. We do this so that we can tell the reader how we know what the answer is. In geometry, reasoning is just as important as the answer itself. Here's our first example. Find the value of x and give a reason for your answer. So have a look at the diagram there. What sort of angles do we have? We've got complementary angles, don't we? They add up to 90 degrees. So our first statement is going to be x plus 51 is equal to 90. And there's our reason in brackets, angles in a right angle. Now all we've got to do is subtract the 51 from the 90, and so x will equal 39 degrees. How about this one? Here we're asked to find the value of angle ABC. So we don't have a pronumeral in this case. That's okay. Angle ABC plus 85 degrees plus 61 degrees plus 90 degrees must equal 360 degrees. And here's our reason, angles in a revolution. Now do you see what happened there? It's okay to abbreviate your reasons, providing the person who's reading your answer understands what you're talking about. So this is a common abbreviation for angle. So this would read angles in a revolution. Okay, now we need to subtract 85 and 61 and 90 from 360. And so angle ABC is equal to 124 degrees. And finally, find the values of A and B and give reasons for your answers. So in this case, we've got two angles that we need to find. Let's start with A. What sort of angles are these? Do you remember? They're vertically opposite and they're equal. So this is a pretty easy question. A is equal to 115 degrees. Have a look at the reason. Vertically opposite angles are equal. Now, what about B? These two are on a straight line, so they're supplementary angles. They add up to 180 degrees. So I'm going to write B plus 115 degrees is equal to 180 degrees. Here's my reason, angles on a straight line. Now let's subtract 115 from 180. Therefore, B is equal to 65 degrees. Okay, that's the end of this lesson. In our next lesson, we're going to look at parallel line relationships.